Hi everyone, my name is Sasha Rubin. I'm a senior lecturer here in the School of Computer Science. It's my pleasure to introduce our two tutorial speakers today, Guido Sciavicco and Giovanni Pagliarini. They both come from the University of Ferrara in Italy. Guido is associate professor there working on, well, as you will see, symbolic learning, and Giovanni is finishing his PhD with Guido. I think being able to see up close and in detail the front edge of symbolic learning at a time when everything is about non-symbolic learning is a real treat, and I hope we'll get some insights. I'm sure we will.
Thank you, Sasha, and thank you for inviting me here. It's such a great pleasure and an honor to be here. It's my first time in Sydney, my second time in Australia, and Sasha and I have very good friends in common. And even if we met in person just today, just these days, we are obviously on the same page on research-wise. This is also the first time we try to put all this work into a tutorial, into a course. And so this is an experiment, and you are the lab, you are the one we are experimenting on. We plan this in 3 days, 4 hours per day. We plan some stops. These stops are not symmetrical, so let's see if you can actually do it in this way. But again, it is an experiment, and it's not going to be just theoretical. Giovanni is here specifically to help me showing things on real data. So we'll be taking turns, and I will explain exactly how. We'll be taking turns and to show how these things work also on in the real world. I want to start by asking myself. I've asked this question myself to myself many times these days. Who is this course for? This material is at the edge between logic and learning. But if you don't know logic, you won't learn it today. Sorry, pun intended here. If you know some logic, then the basic stuff I will go over. You will see, okay, this is easy, not very hard. But if it is the first time you hear some terms like satisfiability, instances, model checking, some things may not completely make sense to you. Of course, here we talk about propositional logics, just for you to have a base, and for us to set up the things we build our material on. And then we talk about modal logics. And I know you don't know modal logics, so our tutorial on modal logic is a little bit more detailed. But again, if it is your first experience with logic at all, then we will have small problems we will try to solve together. And again, if you don't know machine learning, you won't learn it today, and this is a big pun intended. But if you have had your hands on classification problems, and you know what accuracy is, you know what data are, and why do we learn from them, and these kind of general ideas, then we have a common language we can work with. So let me please ask you guys, what is your experience in these two areas, just to understand who I'm speaking to? So just, I know you all right, you told me that. Do you have any experience in machine learning? You suppose so?
Yeah. So the story is that I'm actually a second to third year undergrad student, but
okay.
I'm here. And perfect. I guess I had a bit of an introduction in some classes.
Perfect. And what about logic?
Yes, also.
Somebody else, just to know, do you have any experience in logics?
A little bit in logic.
A little bit?
Much more machine learning.
Much more machine learning. So you know neural networks, you work in subsymbolic machine learning. Same for you? Yeah. Okay. What about you guys?
So I come from a bioinformatics background, so machine learning, yes.
Yes?
Logic,
Not so much.
not so much, yeah.
That's okay?
Logic, no.
Logic, no. All right, let's see what we can do about it. And then, what about machine learning?
Yes.
Yes. Same groups here? No. Or at the same group. Good, perfect. All right, so a bunch of machine learning practitioners here, which makes some things easier. So when I'll tell you decision trees, then you say, that's old stuff. That's probably your reaction. And there's you don't think so? Okay.
I like them.
Oh, you like them? Perfect. Okay, so we have something we can talk about. Good. So I know and I understand now that when it comes to some formality in logic, I have to go slower. Okay. Please interrupt me anytime. Ask any question. There are no stupid questions, of course. There are stupid answers, which sometimes I will give you. And if I don't react to your question in English, try Spanish. If I don't react in Spanish, try Italian. If I don't react that, just throw me something and I will certainly answer you. Okay then, program. So day one, some basic propositional logic for learning, which is basic propositional logic that even if you don't have experience in propositional logic, you will understand this. This is easy. Basic modal logic for learning. This is a little harder. It would be hard even if you had a previous experience in modal logic, because if you had, you'd probably focus on something, on different details with respect to the one I'm focusing on today. But again, we'll stay at a very superficial level. And then we'll cover some initial, very basic symbolic learning concept like decision trees and other models. There is nothing new here so far. There is nothing new here. And because we want to do things also on the practical side, well, we'll have something there in between. I will go over in a minute. Tomorrow is the real deal. Tomorrow we'll talk about symbolic learning at the model case. And so what we're going to do is we put these things together into a new set of ideas. And then if we do our job right, then by end of business tomorrow, you will understand what is everything about, okay? Once we covered unstructured data as model data, unstructured data as model data. So up to that point, I won't accept any any complaint. After that, if you don't like it, then you're free, because I mean, here is what everything is about. What we're going to do in day 3? Well, we throw in some details that makes all this stuff it brings it from the theory to the practice. Okay, it is not necessary for the whole things to work, but if we know feature selection, if we understand how to produce statistically solid results, and if we can use all the concepts you already have from learning, that this is not just a game, but it's something that you can actually work on. The green lines are the ones in which Giovanni will take over, and he will show you how to do this in practice. And how is he going to do it? Well, is he going to do it by using our package? Because this is not just something that we've done on paper. This is a package that we are producing at the moment. It's open source. It's written in Julia. It's probably a language you don't know. It doesn't matter. He will tell you everything you know about it. You have to know about it. And it is it is open for everyone, not just to use it, but also to contribute. It's not a toy package. It's something that it should be, or it is intended to be, as an alternative to packages such as Weka or Scikit-learn, if you will. Of course, it's much younger than that, and there's only a few people working on them, not hundreds of them. But it is a serious alternative. It's not a competition, because we only have symbolic methods over there, and yet it is structured in such a way that you can actually use it hands-on. It is being used right now in the industry. So it works, even if it is very young. And because this course is, or this tutorial is also about this package name is Sole, it would be nice to go over its structures right now. So this is how it is at the moment, and it's got 4 released packages. By released, we mean that the Julia community knows about them, they're official, and we've presented them at the conference for Julia, the conference for the language Julia, JuliaCon. It's an yearly conference, and Giovanni goes there every year, and he presents small pieces of the package and show everyone how to use them. This part here, this 3 package, we call it the core because it has everything you need to know, you need to have, but the learning algorithm, but the algorithms that you use to manipulate knowledge. But as we speak, as we try to explain this package to other people, we realized how the package should be. So we prepared a schema that is much more complete. This does not represent how the Sole package is right now. It represents how it should be, and it probably will be in a few months. We can go over this because if we understand the structure, we are already a quarter of the way there. So what do we have here? We have the part in which you learn things from the data, so symbolic learning algorithms on the right-hand side. You have the part in which you can analyze the knowledge that you have learned, because our knowledge is symbolic, you can analyze it. This is the motivation of everything. You have the part in which you analyze the data by using standard techniques, only raised to a more expressive level. And then you can wrap everything up into an experiment. This is what it's going to show to you. It's going to show to you, not today, not tomorrow, but on day 3, a full experiment from scratch to the model and its evaluation. Okay? So this is the Sole. Sole means in Italian is sun. It is inspired by the fact that our knowledge is clear. You can see, actually. You can manipulate it. And this is exactly what we're doing right now here, because one of the reasons we here is also because we started a collaboration with Sasha, with Guillermo, they're expert in the logic, on the logic side, and now they say, okay, now you're able to learn things and to learn knowledge and express this knowledge in some logical language that was never used before, but we know this logic language very well from other for other purposes. Now we can join forces and we can do something about it. That's the purpose of it. And of course, we can't start. We cannot start a meal without an appetizer. Hopefully, to get you involved and motivated. Now, Giovanni will show us what this is all about without explaining everything. You will learn it, you will understand it by end of business tomorrow, I hope.
Yeah, throughout this course, we're going to see some bits of code using the already released packages. Yeah, so right now I'm going to show you something that is, like a summary of what you can do if you have a framework where you can represent logical formulas, where you can represent symbolic models, and if you have a machine learning algorithm that extracts symbolic knowledge, meaning knowledge encoded via logical formulas. And all of the codes that I'm going to show you are in this repository, which I sent the link around. Okay, and this repository has, apart from the instructions for navigating through it, these Jupyter notebook. These Jupyter notebooks, which apparently also work with Julia. And yeah, so have you heard about Julia? How many people know about Julia? Oh, okay, okay.
Oh, that's
Okay, because in Italy, apparently, I mean, at least in our university, it's not
use it for
common.
of course.
I use it for,
Julia ML.
Machine learning package.
no, I've used it for reinforcement.
Okay, so that's great, because I thought I wasn't going to spend too much time on it. But if you are not familiar with the syntax and you see something that is not familiar, please ask and we can explain. Usually those things do not take too much time. Okay, so okay, so okay, let's start with a machine learning problem. So a time series classification problem is, in this case, it's a gesture recognition problem. So I have a data set of 360 recordings of done while while a person was performing some gestures, okay? And each recording is a time series where there are 24 variables, and these variables are the x, y, z coordinates of their arms, of different parts of their arms, while they perform the gesture, okay? And these are evolved through time, so we have, for each variable, we have 51 temporal points along a temporal axis. And so I have a data set of these objects. Each one is labeled as belonging to one of these 6 classes. And these, by the way, are, I mean, they're probably part of they're probably the gestures that they use for parking aircrafts or stuff like that. And yeah, so the task is you have to train a model for classifying new time series of the same kind. And this problem, if you use neural networks, you can achieve nearly optimal accuracies. But of course, we are here because that's not all that you need. If you want a formal verification that your network satisfies given properties, you want to know how it thinks, how it gets to the solution, right? How it classifies the instances. If you use and the problem with neural networks is that even small neural networks, even two layers, non-convolutional, just linear neural networks are hard to comprehend. And if you don't look at I mean, you can use simpler models like non-neural models like SVMs. In that case, the accuracy decreases. And historically, decision trees have been around since 40 years, and CART is almost, I mean, it's pretty much the state of the art even today for learning from data. Except CART cannot natively deal with this kind of data. Yeah, so let's see what I mean by that, because there is actually a CART implementation in Julia. So here, if I import Sole, Natops is one of the example data sets that I can load. What it does is it connects to the internet and it downloads the data set from the original source. And the data set is composed of so it is essentially a table where you have a row per each instance, and you have 24 columns, one per variable. For example, the first one is the x component of the hand tip of the left hand, and then you have all of the variables. But in each cell of this, this is a table. Sorry, maybe it's not clear, but yeah, it's a table. In each cell, I have actually 51 points. So it's an array, right? Because this variable evolves through time, and yeah, and the labels for these are just strings in this case. So this is what the recordings look like. I have taken one per class. And if you look at these, it's pretty likely that you can come up with simple rules that tell these apart. It must take some time, but if you focus on one of the variables one by one, you probably can come up with some thresholding that, manually, that can tell those apart. But another thing is to do it statistically, to get the right threshold that divides the data set in the correct way. And this is what we are going to automate. Okay, these are all the instances per class. And now, if I use the official decision tree classifier that is available in Julia, it fails because it expects, it's just saying, so before learning, it says, you're giving me a table where with things that I'm not sure I can deal with. In fact, it fails at some point. So essentially, the decision tree is only able to deal with tabular data, with tables where you have scalar values essentially scalar values or categorical values in the cells. Okay. So I can try to take my natops and feed it into a table. For example, if I compute the length, I'm broadcasting the length function into every cell in the table. I see that every cell is a vector of 51 points. So, for example, a very simple way to transform the data into a tabular form is to enumerate all of them. So, for example, I can have a variable for the first point of the first variable, the second point up to the 51st, and then all of the other. So this is very stupid. But this is a way of doing it. This is a way of taking the data, pre-processing it, in order to be able to use a decision tree, okay, which ultimately would look like this. You can get an accuracy of 60%, which, it's not bad for a problem with 6 classes, considering the kind of decisions that it takes, which are of the kind, if the 26th point of that variable is less than a threshold, then you do something. For example, it's this class. Okay, but okay, you can do other things. You can check the other way of doing this in the repo if you take time to go through it. But ultimately, yeah, what we ultimately want to do is we want to be able to perform some temporal reasoning with these things instead of destroying the temporal axis in any way before feeding it to the model. We want a model that extracts some temporal patterns. Okay, so this is what this course is about. We lift the traditional symbolic learning literature and the algorithms, well-known algorithms like the decision tree, to a formalism that is more suitable for temporal reasoning, for example, or spatial reasoning. We can also deal with images, in fact. We get to higher accuracies. We get objects that are tree-like and which you can sort of understand. If you know how to read them, you can do interesting things with them. For example, you can have class formulas, meaning you can have logical representations of what a class is. So if this pattern is true on an instance, then I'm going to classify it as this class. So when a new instance comes in and it is classified as spread wings, for example, I can look at this and I can see what was going on, why the model made this decision. And this is pure interpretable knowledge. Neural networks, even if you have a small one, as I said, it's difficult to understand how they think. This can grow, of course, but hopefully it doesn't. For example, in this case, these are really simple. But still, we look at them and, throughout this course, you're going to learn how to read these, but then you can also translate them to natural language. For example, here we have a really simple one which completely defines one of the classes. Okay, I have command, which is this first class, right? The person goes like this. And yeah, so this says, if there exists an interval where the fifth variable, if there exists an interval in the time series where the minimum of the fifth variable is higher than a certain threshold, 0.85, and all intervals are such that the first variable never goes beyond 0.43, then this is I have command. And this is a logical characterization of, well, not exactly this gesture. It doesn't completely describe this gesture, but this suffices to tell this gesture apart from the other 6. Okay. And again, this is pure knowledge, and if I was an expert in the field of gestures, I could look at this, I could tweak the thresholds if I see that something is wrong, and I can interact with the model in a way. And also, if I have knowledge, like knowledge that come from, say, another model, I can mix them. So yeah, really, Sole, what the core of Sole is about is to be able to represent these kind of objects, these rules, these formulas, to have this notion of interval to perform temporal reasoning.